Okay, guys, so 4.1 note said simplifying rational expressions, okay? We have some vocabulary here. Our first one says, what is a rational expression? So rational, students, is a word that's similar to ratio, right? And ratio is a fraction. So a rational expression is a quotient. A quotient means fraction of two polynomials. What are we never allowed to divide by? We can never ever divide by 0. What are domain restrictions? Okay, so again, domain restrictions, sometimes we also use excluded values. Since we cannot divide by 0, we must exclude all values that will make the denominator 0. How do we find them? Ooh, I'm missing a letter here, guys. So how do we find them? We set. Okay, I'm missing a word here. No, my pen's not working. Oh, there you go. We set the denominator equals, look at those typos, to 0 and solve. So we set the denominator equals to 0 and solve. Number 4, why are you allowed to divide the numerator and denominator of a fraction by the same value? Dividing or multiplying the numerator and denominator by the same value will not change the original expression because it is like multiplying or dividing by 1. So, i.e., for example, if we were to go and give you, let's say, 1/3, and we want to go in and multiply the top by 7, what we multiply to the bottom and the top, they have to be exactly the same. But guys, what's really 7 divided by 7? That's 1, right? Now let's just say that we don't know that and we're going to multiply it out. When we multiply horizontally. 1 times 7 is 7. 3 times 7, that's going to be 21. Well, when we get a fraction, we have to reduce. So we have to go and divide the top and bottom by 7 because they both have a factor of 7 in them. So now we're back to 1/3. So as you can see, multiplying and dividing by the same thing will not change our original expression. Number 5, explain the difference between these two problems. Remember, these are the common mistakes here, so that's why we want to bring this up. We have 5x over 10. So 5x over 10, as you can see, 5 and 10, they both have a factor of 5 in them. That's their greatest common factor. So we want to go in and divide this by 5. What we divide to the top, we divide to the bottom. So in essence, we're dividing by 1, okay? We're not changing anything, but this will allow us to reduce. So 5x divided by 5, that would give us x. 10 divided by 5, that's going to give us 2. This is reducible. It gives us x over 2. Over here on the right side, it has x plus 5. This is a binomial. And then the bottom has a 10. That's a monomial. This is not reducible. So what I would like for you guys to do is take a minute or two and write enough, okay, a sentence or two that will help you understand or know when to reduce and when not to reduce, okay? So on the left side, we are reducible because we have a monomial divided by monomial. On the right side, it's not reducible because we have a binomial reducing or dividing by a monomial. So you guys write that out. So here are the directions for some of the examples. For the following examples, simplify each expression, that means reduce, state any restriction or excluded values. So our number 1 says 45 divided by 105. Well, as you guys can see that they both end in 5, so we know at least they are divisible by 5. Start there, okay? Now, what we want to do is, okay, 45 divided by 5, that's 9. 105 divided by 5, so start with the 10. 10 divided by 5, that's going to be 2, no remainder. 5 divided by 5 is going to be 1. Well, 9 and 21, guys, we still have a common factor. Both are going to be divisible by 3. So that will allow us to say 9 divided by 3 is 3. 21 divided by 3, that's 7. This is as far as we can go because we don't have any more common factor. Now, excluded value, right? The denominator can never ever be 0. Well, 105, guys, is never ever 0. So for this one, we have no excluded values, okay? Number 2, we have 6x to the 4th times y divided by 15x squared times y to the 5th. We have denominator of 15x squared times y to the 5th. So we are going to take the entire denominator. So this is your excluded values. Okay, take the entire denominator and we are going to set it equal to 0. Well, guys, these are different factors, right? So we are going to take each factor and we set it equal to 0. Is 15 ever turn into 0? That's not even something that we need to worry about because it's not a true statement. Well, next one is x squared. X squared equals to 0. Well, x squared equals to 0, we have to do what? How do we solve for x? Take a square root. You're right. So when we take a square root to both sides, well, square root of 0 is still going to be 0. So x is going to come out to be 0. But when we write excluded values, guys, we say x can never be 0 because that will make our denominator 0. So again, when you write excluded value, we say what it cannot be. Then the next one, y to the 5th equals to 0. Similarly, we are going to take each factor and we are going to set it equal to 0. Then again, guys, we are going to take the 5th root of 0, okay, to both sides. So the 5th root to both sides, that will allow us to say, okay, y equals, well, 5th root of 0 is still 0. But remember, when you write the excluded value, we're going to say y can never ever be 0. Because if x is 0 or y is 0, it will make our entire denominator 0. So we can't have that. Now let's go and reduce. I'm going to write the question over again over here since I use up all of the space on the left side for reducing. Okay, so we are going to reduce here. All right, so let's look at the numerical. 6 and 15, guys, we can divide this by 3 to start. 6 divided by 3 is 2. 15 divided by 3 is 5, okay? Now look at the x to the 4th. X to the 4th, students, we can divide that by x squared, okay? So when we divide by x squared, we are going to have x squared left. X squared in the bottom divided by x squared, that will give us 1. So these are, again, all multiplication. Next, I'm going to get a different color pen really quickly. We don't need white at all. Okay, let's get this one. Okay, let's get purple. Okay, so next we have y to the 1st. You don't see a power. And then y to the 5th. They are both divisible by y to the 1st. So y to the 1st divided by y to the 1st is 1. Y to the 5th divided by y to the 1st is now y to the 4th. When you are dividing, we subtract the exponents, okay? So on the numerator, we have 2 times x squared times 1. On the bottom, we have 5 times 1 times y to the 4th. This will allow us to multiply them out. 2 times x squared is 2x squared times 1 is still 2x squared. On the bottom, we have 5 times 1 is 5 times y to the 4th is 5y to the 4th. And box it up. So again, box up your excluded values and box up your final answer.